Good morning, class. Um, just wanted to share with you the actual solution to test two. Okay. Now, for number one, when ideal gas law equations are typically used, the question is asking what temperature will be used in those kinds of equations, and the answer will be Kelvin. Okay. It is very important to know that the temperature, when it comes to any kind of kinetic theory or ideal gas laws, you have to use Kelvin or as a temperature, okay? Not Celsius nor Fahrenheit, okay? Those have to be actually converted um, into Kelvin. Okay, so for number two, they're asking us to convert 75 Celsius to Fahrenheit, degree Fahrenheit, okay? Here's the actual conversion um, equation. So we're going from Celsius, or actually, if you want to be able to find Celsius, this is the actual equation that you would use. But we can manipulate this equation whereby we can find Fahrenheit. So what I did here was just rearrange the equation, okay, to solve for the Fahrenheit temperature. And then typically when you do that, you just now plug in your 75 degrees into that equation, multiply by 9/5, and then add 32 to it. Then you'll get your temperature in Fahrenheit, which is 107 degrees Fahrenheit. Number three is asking us, in terms of a liquid, as it pertains to a phase matter, that does it have a volume but no definite shape, and that would be true. Okay, so liquid is a phase matter that has a definite volume but no definite shape. Okay. The fourth question is asking us how many kilocalories of heat does an expenditure of 250 kilojoules produce? So we are typically and this question is really testing you, two things. One, the notion of heat and how it actually produces energy, and also it's testing you in terms of your conversion as well. Okay, so we're going from kilojoules to kilocalories. Okay, now the established conversion of 1 calorie to 4.1 joules can be seen here. So we multiply that by our kilojoules, and then the kilojoules, the K is just 10 to the 3. Okay, and then we implement our equation to simulate this setup, and then the joules can cancel each other out, and then we're left with 59,523.81 calories, and then the question is asking us to convert that into kilocalories. So with the 59,523.81, we're just moving the decimal places over 3 times. 1, 2, 3, making it 59.5 times 10 to the 3 kilocal. Number 5, calculate the amount of heat in kilojoules necessary to change 200 grams of ice at 0 degrees Celsius into water at 50 degree Fahrenheit. So this particular question is testing, again, two things in particular: your conversion, and also how to utilize your equation, whereby you are using heat energy to transform ice into water. Okay. So the first step, of course, you have to convert your 50 degree Fahrenheit to Celsius, which is 10 degrees Celsius. And the second, you have to convert your 200 grams to kilograms, which is 0.2 kilograms. And this just makes your transition a lot easier. The equation would be the actual heat energy to melt the ice, okay, and then also the temperature, okay, that's also going to be needed. And so we have here the equation is going to give us the mass times the latent heat of fusion plus our mass times our C times our change in temperature, okay. So the setup can be seen here. 0.2 kilograms will be our mass, okay, and there's a reason why, because the kilograms are canceled out this kilograms, okay, because the latent heat of fusion can be also written in grams, but just to make life easier, you just want to be able to make the units kind of the same, okay. So the grams cancel out there, so we're only left with kilocalories on this part of the equation. The kilograms cancel out this kilograms, the Celsius cancel out this Celsius, and then we're left with kilocal on this side. When we add everything together, we're going to get 18 kilocalories. So we want to be able to convert that kilocalories down into kilojoules. We know that 1 kilocalorie is 4.184 or 4.2 kilojoules. And once you know that conversion, this is the conversion, okay, now you can successfully go from 18 kilocalories to kilojoules, which will be 75.32 kilojoules. Number 6, how would you define the unit of pressure? So the unit of pressure in terms of metric can be Newton divided by meter squared. So all this is saying is Newton is what? A unit of force. And meter squared is a unit of area. Okay? So it also can be written as Pascal. Okay? So 1 Newton meter squared equals 1 Pascal. Okay? So when you ever see PA or MPa, it just means megapascal. Okay? That's, the M stands for mega, and the mega is 10 to the 6. Okay? So for a British unit, it's going to be pounds per square inch, PSI, pounds per square inch. That's how it's typically being pronounced. So the question, or the answer to this question, is going to be all of the above. Okay. Number 7, in Bohr's law, in Bohr's law is the temperature and volume constant. You find this more explanation on page 129. So Bohr's law typically states that the pressure is inversely proportional to the volume, meaning that the pressure is inversely proportional to the volume. So as your pressure increases, your volume decreases. So in this case, this answer is going to be false. Can electromagnetic waves be used as a means of transferring energy? Question number 8. More information can be found on page 142, and the answer is true. Okay, waves, of course, are a medium of transferring energy. Now, when we're talking about electromagnetic waves in particular, the use of wavelength of light as a function of energy. Okay, therefore, energy, of course, is inversely proportional to the wavelength. So meaning that my energy will actually, let me take it from other section. If my wavelength of light is smaller, my energy increases. Okay, so that's why gamma rays, which has a very very shorter wavelength of light, is going to be high in energy. Okay, likewise, or conversely, I should say, for infrared, has a longer wavelength of light, is going to have a very smaller energy. Okay, so again, these waves can be used as a medium of transferring energy. Okay. The question here is asking us, is Fe, which is iron in your periodic table, a better conductor compared to Cu, which is copper in your periodic table? And you find more information here on page 122. Answer is false. Okay, so just kind of keep in mind that conduction is a transfer of heat, when these molecules typically begin to collide. And so it all goes back to how your molecules are being binded together, because you have what you know as a metallic bond, covalent bond, ionic bond. But in this case, these are both metals. So there's a lot more that goes into why one is better than the in terms of a conducting of heat compared to the other element. So, but just kind of keep in mind that there's going to be a lot of molecular collision, okay? And when things are colliding, they're transferring, they're being able to transfer energy, okay? So again, as I said, look at the table on page 122, and this particular question really was testing you to see how can you use tables to answer a question. Okay. So number 10, in a case where a solid can change directly from a solid to a gaseous state will be called deposition, and the answer will be false. Okay. The deposition is where you go from a gaseous state to a solid state. In this case, we're going from a solid state to a gaseous state, which would be sublimation. An example of that would be dry ice. Okay. Is it true that water has a higher specific heat than alcohol? And the answer is true. Again, if you go to page 115, you'll find more information in that table that that itemizes the actual specific heat of different contents. Okay, so again, always just keep in mind that when we're talking about specific heat, we're talking about the temperature, the amount of heat that's necessary to raise temperature of 1 kilogram of substance, the mass, by 1 degree Celsius. Okay. So that also goes into the molecular structure and also how the molecules are being binded together. Okay. Number 12, what kind of wave has a behavior where the particle motion or displacement is perpendicular to the wave velocity? Again, you can find more information on page 143, but the answer to that will be your transverse wave. Your transverse wave is a phenomenon whereby the particle displacement is perpendicular, okay, to the velocity or the movement or the motion of that particular wave. Number 13 is asking us, how would you characterize a wavelength? Okay, so you can see graphically here, okay, you can see graphically here the velocity of the wave, and of course it's being characterized from one point to the same adjacent point on the next peak. Okay, so just kind of keep in mind that this is how you define one wavelength of light. Okay, so it's a distance from any point on the wave to the adjacent point, and it'll be from this point right here to this point right here. Okay, I'm going to stop here and I'm going to continue. Okay, thank you very much. Thank you. So picking back up from number 13, I want to go into number 14. What kind of wave has a behavior where the particle motion is parallel to the wave velocity? So again, this is the actual velocity of our particular, the actual velocity or propagation of our wave, okay? And the particle, of course, displacement is going to be parallel to the velocity of the propagation of that particular wave. Okay, so that's going to be a longitudinal wave. Okay, number 15 is asking us, how would you describe frequency of a wave? And again, you can find more information on page 144. So the number of cycles that occur during a given period of time is usually 1 second. Okay, so that's typically how you would define your frequency of a wave. Now we have, again, these questions are really given to you to see how you can identify certain definitions. Okay, or how can you explain or know what certain terms mean. Okay, now number 16 is really now going to be testing some of the application of those concepts. In this case, we're looking at the wave period of a wave with a velocity of 4 meters per second and a wavelength of 3 nanometers. So 3 nm. The N stands for nanometers. Okay, so here's your established equation here showing the relationship between the velocity of the wave to that of the wavelength and the period. So now you can, since the question is asking for the period of the wave, which stands for the t, we can manipulate the equation now and solve for the period. Okay, so here, this is your 3 nanometers divided by the actual velocity of the wave. The meters cancel each other out. We have seconds on top. So, and this would typically be our answer, 7.5 times 10 to negative 10 seconds. Okay. Now, number 17 is asking, what is the wave period, right, of a green wavelength of light, which is 510 nanometers, traveling with the speed of light, 3 times 10 to the 8 meters per second. Again, this is our established equation showing a relationship between the velocity and the wavelength and the period. We can manipulate the equation, and this is what we have as an outline here, and then we could cancel out the meters, and we're left with seconds. So if any time you're doing any kind of calculation, try to spell out your units, because when you do that, typically what happens is whatever you're solving for, those units should be left behind as an indicator that you're on the right track. Okay. Number 18. Yes, it is true that accelerated charged particles produce waves of different frequencies that form an ongoing electromagnetic spectrum. Okay, so just kind of keep in mind that when charged particles like electrons are energized, of course they're going to accelerate and radiate energy from or away in the form of waves. Okay, so as I said before earlier, waves with a low frequency have a low energy. Okay, you can find more of that information on page 146. This question again in number 19 is testing your ability to look at tables, okay, and answer a question. So what is the appropriate sound intensity in decibel level for a quiet room? And of course, you find that information on page 150, and it's going to be 20 decibels. Okay. Number 20, they're asking us about gamma rays. Of course, it's part of your electromagnetic spectrum. Again, this question is just really testing you. Can you look at a chart or look at a diagram and pick information or find information from that diagram? Number 21, yes, it is true that most structures are capable of vibrating at their natural frequencies. And this typically is being defined to us in page 159, letting us know that this concept typically comes from standing waves and resonance applications. Number 22 is true. The answer is true that wave motions of speed depend on the elasticity of the medium. And again, you'll find more information about that on page 148. So without getting too deep into the chemistry, of course, these wave motions, or the speed of these wave motions, of course, they do depend on the elasticity or how pliable the actual medium is. Number 23, we have a question here that the constant force of 150 newtons is used to push a student's stalled motorcycle 32.81 feet along a flat road in 0.0055 hours. Calculate the power used in watts. Okay, so this question is just really testing you two things: conversion and how would you apply the unit or the equation of watts. So here's our equation, established equation, letting us know that power is a product of the force and the distance divided by the time, making it a rate. Okay, so the step one was to convert your feet into meters. So we had 10 meters will be the equivalence of 32.81 feet. And then our hours will be converted into seconds, which will be 20 seconds. And then we can just plug and play in the equation, giving us 75 watts. Work is always a scalar quantity, okay? Force is a vector. Work is a scalar quantity, okay? Number 25, again, this table, this particular question is really testing to see how you can utilize table and extract information. So here, the table 5.2 on page 119 is illustrating that water has a greater latent heat of fusion than nitrogen, okay? So always keep in mind, if you kind of forget um, what latent heat means, it's just the amount of energy it's going to take to initiate a phase change. Okay, so I hope this helps. Um, I just wanted to give you the solution so you know where you can um, look up where have some kind of explanation as to what answer you might have gotten wrong. And then if you have any further questions, please just let me know. Thank you very much.